Hi, this is Stu Bruce from Washington College. Today I'm going to give a demonstration of our least cost path analysis lab exercise. We're going to use the least cost path tools to determine the most likely migration route from point A to point B. This is often used for animal studies, but the theories can be applied to criminal behaviors as well. You're going to have to download the data from our Geo Workshop site to do the exercise. When you do, this is the data that you should end up with in a folder called Path Data, wherever you decide to store it. This is what it would look like if viewed inside ARC Catalog. Now our scenario is to try to figure out what the migration route for deer would be from the northern part of York County to the southern part of York County. There's a lot of deer in York County and Pennsylvania in general, and having an understanding of how they might migrate from one place to another can help you plan possibly to avoid car and deer accidents, which is a very common thing in Pennsylvania. Just to give you a little bit of overview of York County, we're going to have deer migrate from the north to the south. There's some obstacles in the way, like the city of York, that's unlikely they'll go through. But what would be the most likely path for them to navigate all of these various obstacles that are not deer friendly? That's the goal of the exercise. Some of the data that we're going to use slope. Deer don't like to go up steep slopes. We'll use land use. Forested areas are deer friendly. Urban areas are not. We're going to use roadways. Deer are going to try to avoid going across interstates. We also are going to use a boundary to container study. We have a destination showing where the deer are going to. We'll use elevation data to determine slope. We'll use a land use layer to determine land use. We have a roads layer, and then we have our source, where are the deer coming from. So we're going to go ahead and start ArcMap, and I'm going to switch over to ArcMap myself. So inside ArcMap, we're going to open up ARC Catalog, navigate to where the data is, and we're going to go ahead and drag all of this data over to our data view window. So here's all the data I'm going to use. Of course, I have my source, which is up here in the northern part of the county. I have my destination in the southeastern part of the county, my roads layer, a county boundary. I have my land use image, which has to turn roads off for you to see that. And then I also have an elevation data set, which I'm going to use to determine slope. So the process that we're going to use here, we're going to have to work on the slope data. We're going to work on the roads data, and we're also going to work on the land use data. First, we're going to work on the slope data set to find the steep slopes. So one of the first things we're going to do is we're going to create 2 empty GeoDatabases to use for our project. So if you come over to Path Data, where your data is folded, you're going to make 2 new GeoDatabases. Simply going to right-click here and go New File GeoDatabase. The first one we're going to call Least Cost Path. Create that one, and we're going to create a second one that's called Least Cost Path Scratch. And the reason we have 2 is we're going through the process. We're going to dump our initial outputs into the Scratch folder, and down the road, if we want to rerun a final, we could go to this final folder. But mostly we're going to use the Scratch GeoDatabase for right now. We're also going to create a new toolbox to put some tools into. So we'll have to open up the ARC Toolbox. So to create a new toolbox, we're going to go ahead and in the white space in the toolbox, we're going to right click. We're going to go Add Toolbox. When we click Add Toolbox, we're going to go ahead and hit this little button at the end there to create a toolbox. We have to make sure we're in the right folder. I'm actually stuck in a folder for another project that I'm working on. So here you can see I'm in the right location. I click the little button here, Add New Toolbox, and I'm going to name it Least Cost Path. And then I'm going to go ahead and click Open, and then select it and open, and you'll see it added over here, we hope. Yep, so right there is my new empty toolbox. Now, one of the things that we're going to do here for this particular project is a little bit different. We're really going to use the model builder to actually model our entire flow. So the first thing we're going to do is we're going to create a new model and save it in our toolbox. So we're going to come over here to least cost path. We're going to right click on this. We're going to select new model. So we're going to go ahead and save our model. We're going to go model, save as, and we're going to save this model as least cost path route. Click save, and notice how it shows up in our model. Now, I could have named that a little bit better, but it's okay if it's named model 1 at the end. Next thing we're going to do is we're going to set our environments tab inside the model. So if we go ahead and open up the model properties again, model properties, we're going to go ahead and select the environments tab. We're going to make sure that we have the processing extent, we have the raster analysis selected, and we have our workspace selected. So we're going to select those 3 items. We're going to go ahead and click the Values tab. Now, if you remember from the last exercise, every time we ran a tool, we had to go in and set these variables. By working in Model Builder, we're going to automatically set these variables for every tool that we use, and we shouldn't have to do it manually. So first, we're going to click on Workspace. We're going to go ahead and make sure that our current workspace is going to be set to least cost path. We're going to hit Add. Our Scratch workspace is going to be set to that Scratch GeoDatabase that we created. There's our Scratch GeoDatabase, and we hit Add. The next thing we hit is Processing Extent, and what we're going to do is we're going to set our extent to match the elevation data set, so same as layer elevation. Next, we're going to set our raster analysis, so we go ahead and click that, and we're basically going to set our cell size to be as specified below, and we're going to go ahead and set our cell size output to be 30, which matches the elevation data set. Then we can go ahead and click OK, and then OK again, and now we can start to use our model. All right, so in our model, hopefully you guys have used Model Builder before. This is actually something that's covered in our GT20 course, but if not, I'm going to kind of go nice and easy on this. But basically our model's open. The way Model Builder works is you can click and drag tools and data to your model. So the first thing that we're going to do is we're going to calculate the slope on our elevation model. So underneath the surface tool drawer, we have our slope tool. We're simply going to drag slope over to the model. You'll see it populated just like this. Next, we're going to drag our elevation over to the model. We'll just drag it over and drop it. And then we're going to use the Connect tool, which is this tool right here called Connect. We're going to click that tool, put a dot here, and drag it inside our slope, just like that. It's going to be called our input raster, and you see everything will become colorized. You can click the auto layout button right here to clean up how your model looks at any time in the process. Now we're going to double click on our slope tool to open up the slope dialog. We can see our inputs elevation. I already have, because I set the default, it's already going to our least cost path Scratch GeoDatabase. It's automatically being called slope elevation 1. And what we're going to do is sometimes you can actually just leave it that, but I'm going to just rename mine to be called slope. Our output measurement's going to be degrees, and we go ahead and click OK. And then we're going to go ahead and run this part of the model. Now to run the model, you simply come up here and hit the run button. And what you'll see is the model will run. You can watch it run. When it's done running, you can close this dialog, and then you're going to right click on the output where it says slope, and you're going to select add to display. And when you add it to display, we can move the model builder window out of the way, and then we can just turn on, there's our slope. So right away you can see some areas between our source and destination where we have some steep slopes. Always a good idea frequently to go ahead and save your model. So we can go model save. Just make sure in case ArcMap crashes on us, we don't lose the work that we're doing. The next thing we want to do is we're going to go ahead and reclassify our slope output. We're going to go with a common scale of 1 to 10, where the value 1 is an area of least cost to travel, and 10 is a high cost to travel. So what we have to do is go back to the Spatial Analyst toolbox under the Reclass tool drawer. We're going to go ahead and drag Reclassify over to our model. We're going to go ahead and connect our output of slope to our Reclassify tool like that. It will be our input raster. Then we're going to double click and reopen the Reclassify tool. We're going to go ahead and click the Classify button. When you do, you get this error. You're going to go ahead and click OK. All right, now we can go ahead and run the tool. Notice how these icons down here have a gray shadow behind them. This means that they've already been run. And when I hit run now, it's only going to run the tool that hasn't been run. So go ahead and hit run. Again, you'll see the dialog run. When it's done, didn't receive any errors, we can go ahead and close. And then we can right click on Slope Reclass and select Add to Display. And now we can go ahead and move this out of the way, and we can actually see our results. So once you're done looking at your results, make sure the tool worked correctly. Go ahead and again, save your model frequently, like that. Now again, the real benefit of Model Builder here is that we're going to be able to reuse this tool later. We can go ahead and modify anything we want into the tool, and we can actually rerun the whole tool again. So it's really great if you want to do various iterations of the same model and see what the different results would get you. Now we can go ahead and clean the model up by hitting our layout button. And the model start getting a little bit stretched out here. The next thing that we're going to do is we're going to go ahead and we're going to work with the road data set. It's currently in a shapefile format, and we're going to have to convert it to a raster. The value that we're going to use for the raster will be route number. The route number will be useful later in the exercise when we classify the cost barriers to roads. We're going to go ahead and use the under conversion tools, under to raster, we're going to use the feature to raster tool. We're going to go ahead and drag our roads over as the layer. And we're going to connect the roads to the feature to raster tool like that as an input feature. Then we're going to go ahead and double click on the feature to raster tool. Our input feature is roads. The field that we're going to use for the value is we're going to use route number. So we hit the drop down arrow, come down here and find route number. We already have the output raster going where we want to, but we're going to rename this roads. We're actually going to call it roads underscore RAST for raster. Our output cell size is already picked at 30, so we can go ahead and click OK. Then we can go ahead and select run. And again, noting the gray shadows here, we've already run these tools. So we're going to go ahead and just click run. It will run through and process in no time at all. Actually, that did take a little bit of time. Once we're done, we can go ahead to the output here, and we can select Add to Display, move this out of our way, and we can now see our roads raster layer. These numbers in the classification really have no meaning right now because they are actually the route numbers. So I went ahead and hit the auto layout button to clean up what I'm doing. The next thing we're going to have to do, just like we did with slope, we're going to have to reclassify our roads raster. So if we go ahead and navigate back down to Spatial Analyst, bring in our Reclassify tool over, we're going to go ahead and connect the roads to our Reclassify, just like that. roads would be our input raster, and we're going to go ahead and double click on the Reclassify tool. Actually, I got ahead of myself there just a little bit, so I'm going to cancel out of the tool. We're going to go ahead and double click on roads raster, and what we're going to do is we're going to do a unique values classification based on the road route number. So we go to symbology, unique values, make our value field is already set to be route number. And what we want to do is go ahead and click OK. We can move the model out of the way. Not that this helps you any at all, but if we went and highlighted basically some of the major roads, if we were to highlight some of the major roads, such as we have an interstate that runs here, you can just barely see it. This is Route 83. We also have Route 30 that runs across the county this way, and we're going to give those a higher cost value than the other roads. If you're not familiar with York County, this might be a little bit hard to understand, but if you just open up York County in Google Map, you would immediately be able to identify which are the major roads in that particular county, and then this might make a little bit more sense to you. Now we can go ahead and open up our Reclassify tool here. We're going to go ahead and click the unique value button here for roads, and then you can see we now have each individual route number. And unfortunately, there's quite a lot of route numbers here, but this is going to go relatively quick. We're going to assign a value of 5 to old value of 0. And then basically a value of no data to the values for Route 30 and 83. So no data, we want to make those, we're trying to make those impossible for the deer to cross. Although the first time I ran this model, it didn't work exactly how I thought it would. So we'll see if we have a difference here. But basically no data for 30, no data for 83, and we're going to assign a value of 7 to all of the other roads. Now I'm going to pause and go through and do that, so you don't have to watch me do that. So when you're done doing that, which the time it takes you is dependent on how fast you can click and type, the last thing is at the very bottom, the no data, old value of no data become a new value of 1. Go ahead and look through, make sure you have everything done correctly. So it should look just like this. You can see our output is going to our Scratch database, and we're going to rename this to be Roads Reclass. Once we do that, we can go ahead and click OK. Now I must have clicked something wrong on mine, so unfortunately I have to do this again. So this time I'm going to go ahead and hit the apply button first to make sure my change is stuck. And now I got to figure out what is going wrong here. So basically I wasn't following my own instructions. As soon as you have the last value put in there, you go back and verify that everything is done correctly. Then click the Save button and go ahead and save this in the correct folder. So we're going to save basically the reclassification as Roads Reclass. We have our output here. Now we should be able to click OK and actually apply that. Now because I've done this 2 or 3 times, I'm going to go ahead and double check to make sure it's saved by opening up my Reclassify tool. And I have to hit load. I'm going to load my Roads Reclass and hit load. And then go ahead and click OK. So this actually might be part of my issue that I had later in this exercise, but we're going to go with it. All right, so now we're going to go ahead and run the tool, but we're going to carefully check our output to see how it works. So we're going to go ahead and click Run. It's just going to run the Reclassify here, which hopefully won't take too long. So when the tool is completed, we're going to examine our output data. But to do that, we have to right-click on Roads Reclass and select Add to Display. And we're going to have to zoom in to see if we have no data where those major roads are. So I'm going to turn off all the other layers except Roads Reclass. And then I'm going to zoom way in on the data. And notice that we do have, for the major interstates that we want to block, we do have this no data in place, which should act as a solid barrier to the deer migration. Now there are ways for deer to get underneath. And what I'd actually done for this model is I pre-prepared the data. In a couple places I blew big holes in the interstates to give deer a chance to get through so we didn't have a total block. You'll see this as I go north. I should have a hole, so I actually created holes. So these could be like underpasses or natural locations where deer could cross. All right, so the next layer we're going to work with is the land use layer. And what we're going to do is we're going to bring the land use layer into the map. So we can just drag that right over into the map, our land use image. And we're going to do an immediate reclassify on that. So we're going to bring our reclassify tool over. And we're going to go ahead and connect land use to reclassify, just like that, as our input raster. And then we're going to reclassify the land use. So I'm going to open up the reclassify tool. All right, so in the reclass window, what we're going to do is we're going to go ahead and click the unique button. So we click unique, and you can see all the different land use values here. What you have to do is actually look at the lecture slide for the lab exercise. These are all the values we're going to change to. I'm just going to go ahead and pause, and I'm going to do all these changes. Now, when you're done setting those, a couple things we have to do. One, we're going to go ahead and save this. So we're going to call this land use reclass, like that. Save. Then we're going to make sure we change missing values to no data. And I'm going to have to go back and reload what I just did, since it reset itself. And that did not work exactly right. I take that back. It did work correctly. I'm saving this as an output raster. It's already going into my Scratch. So I'm going to call this land use reclass, RECL. And I'm going to go ahead and click OK. Now I can go ahead and run the tool. So I'm going to run the tool. It won't take very long to actually run. And then I'm going to click on this and add to display. And then I'm going to examine my results. So if you zoom out a little bit, you can see like these green areas are very conducive to deer traveling. We come down in here to where we know the city of York is. So you have a lot of 8s, 7s, and 9s. So the deer are going to want to try to avoid that area. Probably either go this way or this way to avoid the city of York. But it looks like the tool ran correctly. So our next step is we now have the 3 outputs that we need to determine our cost surface. And we're going to combine these 3 cost surfaces. We're going to weight them based upon a weight that I've determined. This is actually the weight that I've assigned. Slope will be 20% of the weight, roads will be 40%, and land use will be 40%. And of course, we're going to use the Raster Calculator to do this, kind of like we did in the previous exercise. So we're going to go to the Map Algebra tool. We're going to go ahead and drag the Raster Calculator over here. And we can go ahead and hit our auto layout button here to kind of straighten this out. Technically, we might want to move the Raster Calculator, grabbing the black arrow here. I'm going to go ahead and move it to be over here. And then I'm going to connect each of my outputs to my Raster Calculator tool. It's going to be a map algebra expression. Then I'm going to drag again, and I'm going to set precondition for each of these. So in other words, before we run the Raster Calculator, these would have to have run as inputs to the tool. Then we're going to go ahead and double click on the Raster Calculator, and we're going to do our equation. So we're going to scroll down till we see the yellow. Our first one is going to be land use reclass. So we go ahead and double click on that. So land use reclass times 0.4 plus, we're going to do slope reclass. So slope reclass times 0.2 plus roads reclass times 0.4. So that's basically our equation. We can see it's going into our output here. We're going to call our output file weighted, like that. And then we're going to go ahead and click OK. We're going to go ahead and auto layout our tool, like that. So really what it's showing us here is it's taking these outputs, putting them in here. We have a precondition that these three have to be done before you run the tool. And if all goes well, when we hit run, this will actually work. So we hit run, bringing it in here, calculating. I'm going to go ahead and put it on pause while it's figuring out what to do. Didn't actually take that long at all. So I'm going to go ahead and close this. I'm going to right click on weighted, and I'm going to go ahead and add this to the display. And I'm going to take a look at it. And what we see here, if we look at the legend for weighted, remember the lower costs are easy for deer to get across, and then our high values are here. So we can see that the whole city of York appears to have pretty high values. We have some no data there, like where water existed, that deer just aren't going to cross. And if we go ahead and zoom in a little bit, what we can see is that we also have some no data where we had the roads go through. Notice that the raster conversion didn't give us a complete, so there's other little areas the deer might go across, but if you've ever seen deer cross a highway, you know it's not a perfect barrier. And of course this area here where I deliberately put gaps in the road is going to really encourage deer to go this particular route. So you see dark here is friendly to deer, lighter colors not friendly for deer to travel through. Now, if I want to see my entire model, there's a button up here I can press, which is, I think this is the right one. This allows me to see my entire model. So you can see everything we've done so far in our model. But we are not done yet. So the next thing we have to do is we have to create what's called the cost-weighted distance and the cost-weighted direction. And we're going to use this weighted as the input to that. The distance data set will show the accumulated least costs of travel for each cell back to the source, and the direction will show what direction that it will follow. So what we'll do next is go ahead and zoom out and take a look at the entire weighted area, and then we can see we have our source and our destination down here. So it's going to go ahead and try to calculate those variables between here and here. So we're going to have to run another tool. Surprise, surprise. So we're going to go ahead and drag our cost distance tool over. And you can see we're going to get two outputs from that. And we're going to go ahead and drag our source data layer over. We're going to connect our source data layer to the cost distance tool, like so. That's going to be our feature source data. And then we're going to connect our weighted output to our cost distance tool. And that is going to be the input cost raster, like so. So now we have to double click on the cost distance tool. And in here we can see that our feature source data is source, our input cost raster is weighted. And what we're going to do here, we have our output distance raster, which we're going to call this distance. And then our maximum distance, we're going to basically leave blank, but we are going to create the output backlink raster. This is really the direction raster. And we're going to go ahead and create a file for that. We're going to put it into our Scratch folder. And we're going to go ahead and call this file direction, like so. Go ahead and click Save. And then we're going to go ahead and click OK. And you'll see the difference there is that it highlighted the direction output because we are selecting that particular option. Now we can go ahead and run this next segment of our model. And this might take a little bit of time, so this would be a great time to potentially get a cup of coffee or something like that. All right, well, mine took several minutes to run. The time it takes to run is really based on the speed of your machine. Once it's done, you can go ahead and hit close. Right-click on distance to add to display. Right-click on direction to add to display. And let's take a look at what our resulting products were. So you can see our distance is really showing the distance from the start going out, and then our direction kind of shows the best direction and angle to go. So with these two files, we can go ahead and do what should be just about the last step in the process. And that is, of course, to find the shortest path. So we're going to use one more tool, and what we're going to do is we're going to add the cost path tool to the model. So if we come back here to our distance tool drawer, we're going to go ahead and drag in our cost path. If you want to, you could try to clean this up. I'm going to leave mine messy for right now. We need to add our destination layer to the model. And what we're going to do is we're going to connect it to here, and we're going to set that as the feature destination data. Then we're going to connect the distance output to cost path, and we're going to call that our input cost distance raster. Then we're going to connect the direction to our cost path, and we're going to call that our input cost backlink raster, like so. And once we do that, we're going to double click on the tool. We're going to make sure it's going to our directory, and we're going to change the output name to be migration path, like so. And then we can click OK. If we want to, now we can go ahead and auto layout the tool so we can kind of see what our next steps were here. Model's starting to look pretty complicated, don't you think? And we can go ahead and hit the run button and hope for the best. There's a run tool. This should run a little bit quicker. So it took 5.41 seconds, not too bad. We can go ahead and close this dialog. We can go right click and add to display, and we can see what our results are. It's a little bit hard to see unless you zoom in some. But see, there's our least cost path from our source to our destination. See it run through here, kind of skirting the edge of the county here and ending up down here. And we can sort of look at some of this. If we come back and actually turn on the land use information, and just kind of, it's what I call like the reality check of your data. You can kind of zoom in, and of course, in our land use model here, these green areas are fields and woods. So we have different types of woods. So you can see how the deer are sticking to the woods. They're avoiding open fields wherever possible. Come up along here, see that they've totally avoided urban areas, sticking to the woods as much as possible. A couple areas like here, they have to cross open fields. If you were a hunter, this would be where I'd set up my deer stand right here and have a nice clear angle of view. And you can kind of make sense. You know, get up through here. Now here's like a little bit of urban area, have no choice but to cross. Come along through here. We've got a river here. They must be swimming across or taking the bridge. Here's the city. They've got to cross through some urban areas through here. Really no choice but to go through some dense urban areas. Probably eat all your shrubs along the way. And then here we hit woods again, coming out here. Notice how they avoided this lake. We have our entire path, and actually when you look at it, it kind of makes sense. They would have avoided this area, obviously, back to the source. So it looks like the tool did exactly what we thought it would do. So the assignment for this class is really just to find, one area where you can zoom in and see the details to sort of show how they were avoiding the high cost areas, and you can upload that as an assignment for the class. There's a second assignment for this class, which is to have you basically use your model builder window. You can make this a little bit bigger, and if we go ahead and use our auto layout and our pull extent, you can actually use the snipping tool. You could snip this model out, paste it into a Word document, and you could write a little bit about how you actually did the model. For our adult professionals, this is really an optional thing for you to do. Now, as a sort of challenge exercise, you could go back in and you could actually move the source and destination points to different areas, and you could actually rerun this model. Once you move the source and destination around, you can come up to your model and go delete intermediate data. It will basically delete all the data that we did, and we can actually run the entire model again at one shot. And this allows you to run different types of scenarios, which is very useful. And if we didn't have the model, okay, we would have to manually go through and do all this again. This is why the model builder application for these complex tools is really a great time saver to allow you to run different scenarios. So I hope you enjoyed this exercise. Keep in mind for our class project that you'll either be picking a least cost path example or a site suitability example for your final project for Spatial Analyst. Have a great day.